Pre-VSEPR Definitions. In this podcast, we're just going to go over a few quick definitions that you really need to know before moving on with VSEPR theory. So we're going to define steric number, coordination number, and the two of those kind of go hand in hand, and then electron and molecular geometry. Now, electron and molecular geometry, I'm going to kind of show you, I'm going to tell you the answers to a couple, but we're not going to learn how to determine them in this video. In this video, we're just going to see the differences between them, and then in the next video, we'll actually walk through how to solve for these for all shapes. And then we'll also talk quickly about bond angle, which is exactly what it sounds like. So first off, steric and coordination number. Your steric number is the number of bonded atoms and your number of electron pairs. So each atom that is bonded to the atom that you're talking about, and each lone pair counts as one. Meanwhile, your coordination number is just your number of bonded atoms. Now to get these, you obviously need to draw the Lewis structure first, or you would have no idea. In this case, I'm just going to give you the Lewis structure. But remember, when you're doing this yourself, if you're just given the molecule, draw the Lewis structure first. First, we have NH3. If we look at how many bonded atoms there are 3. And therefore, its coordination number is 3. But if we look at its steric number, we have 3 bonded atoms, but we also have 1 lone pair. So that gives us a steric number of 4 and a coordination number of 3. Let's look at another one. Here we have phosphorus pentachloride. We have 5 bonded atoms and no lone pairs this time. Now you might be saying, oh, there's a lot of lone pairs though. Look at all the lone pairs on the fluorine. And while that may be true, the lone pairs on the fluorine don't count because we're talking about the geometry of the phosphorus. So there's a coordination number and a steric number of 5 because we have 5 bonded atoms. Each geometry is going to be speaking of the central atom. If there's multiple atoms, each atom can have a different steric and coordination number, but each atom will have its own steric and coordination number. Don't just add them all up. So now let's look at bromine pentafluoride. Now notice in both cases, here and here, we have pentafluoride, but something changes because with the bromine, we also have this lone pair. For our bromine, we have a 1, 2, 3, 4, 5 bonded atoms and 1 lone pair. So our coordination number is 5, just like with the phosphorus pentachloride, but our steric number is actually 6. To determine these, you draw your Lewis structure, you count up your bonded atoms and your electron pairs, and that tells you your steric and your coordination number. Now we come to the part where we're not going to go over exactly how to do this. It's a much longer lecture and we'll cover that next time. But the difference between electron geometry and molecular geometry. Electron geometry is the geometry that you might have if you quote unquote saw the electron pairs. It's as if we're counting that as part of the geometry. And when we name these, we're going to name them as according to the electron geometry as if you see the electron pairs. Now, with molecular geometry, the electron pairs still has an effect. So you can't just ignore the electron pairs. However, the nomenclature is going to wrap around the idea that you're not seeing, quote unquote, these electron pairs. That while they are adjusting the geometry, they aren't playing a role in the geometry. And this will make a little more sense after the next video, but we just need to introduce the definitions here. Now, if you have a situation where you don't have any electron pairs on your central atom, for instance, with our phosphorus pentafluoride, this is always going to be the same. So we'll learn about why this is next time, but because we have 5 bonded atoms and no lone pairs, we're going to have a trigonal bipyramidal structure. The next video will talk about how to determine that. But notice that the electron and the molecular geometry are the same. Now, if you have lone pairs, these are not going to be the same. So here we have 3 bonded atoms and 1 lone pair. Now, what we'll see next time is that this gives us an electron geometry. If you have 4 things, 4 bonds, 2 bonds and 2 electrons, whatever it is that adds up to a steric number of 4, that's going to give us an electron geometry of tetrahedral. However, if we now say, well, we know this lone pair is affecting the geometry, but we're going to act as if we can't see it as part of the geometry, we get something called trigonal pyramidal. Your electron geometry is always going to be based on steric number, while your molecular geometry will have to be based on steric and coordination. And we'll see how this works exactly next time. So one more, for instance, our bromine pentafluoride, it's the same situation where because we have a lone pair here, they aren't going to be the same. We would name our electron geometry based on the fact that we have a steric number of 6, and we'll see next time that that's called octahedral. And with the molecular geometry, we act as if we can't see this. It's still affecting the shape, it's still changing the shape, but it would be square pyramidal. So this entire system that we're going to get into next time is all based on moving the bonds and the lone pairs as far away as possible. That's what VSEPR geometry is all about. And the shapes that these take are going to depend on how many things are attached to it and how many lone pairs we have. And that's going to give each thing a different name. We'll talk about how to determine all that next time. Now, one other quick thing that we need to talk about is bond angle, which is exactly what it sounds like. It's the angle between two bonds. And we're not even going to touch the name, how to determine these on this video. We'll see it next time because it's based on the geometries and it's too much to go into until you've had that. But just know whenever we say bond angle, we mean the angle between two bonds. So in this case, the angle between those two hydrogens, here the angle between the two fluorides, and here the angles between two fluorides. We do not generally talk about bond angles being between a lone pair and a bond. That's just, it's not a bond angle. You could talk about that angle if you wanted to for some other purpose. I'm not exactly sure what purpose you would use there, but you definitely have something called bond angles that we're going to be talking about, and you're going to have to know those once we get there. So now you have a general idea of what steric number, coordination number, and a vague idea of electron geometry and molecular geometry. These are going to make a lot more sense when we cover them next time.